In this next video, we're going to go over the actual classification algorithms and how that ties into our work item system. So again, when creating any type of algorithms, we're going to go to the projects, and within the projects, it's like a folder that would house all the different types of algorithms that we're going to create, from clustering, classification, and regression type models. So when we're making a classification type algorithm, at least in our cases, most of our studies have included giving raw data with no perception as to actual critical events. We do an anomaly detection type algorithm on that data set and determine what anomalies have occurred within that data set. And then from there, we would investigate and actually do a classification algorithm on those anomalies to determine what tags associated or had the highest contribution to that specific error or critical failure, and to also see what kind of lead time to failure we can occur or we can predict from that type of failure. And again, the project is where we house all of those algorithms itself, like a file type system. And then the work item aspect is where we would put the actual critical event information. So let's say in some cases, the customer will give us the actual date and time of a specific failure, the downtime that it took to fix the issue itself, and how long the system was offline, cost, and some of those other type of metadata that we will take in. But for here, what we're going to do is kind of show you a few different ways how the classification and the work items kind of go hand in hand. So here in the work items, we can actually create a work item, which would allow us to give a name, the date, what data set is associated to, the cause, pre-process time, post-processing time, and then the downtime of the instrument, and some of the metadata that is cost and what were the main causes that the engineering or mechanic or reliability teams would actually tell us what occurred there. We can actually export all of these items into a CSV type format so that we can look through and actually either create or adjust as needed. So again, kind of like the smart data collectors, if we were doing one tag at a time, for 10 tags, that's not a bad setup. But when you're doing maybe 100 events within a data set, it is recommended to export work items and then add on all of these separate work items from either CMMS type format and then bring that back into the system so that now it has all of those work items imported. And so what I'm going to do first is go over how we create that work item, go over a little bit of the CSV file format. And again, the importing is self-explanatory. It would come in and set itself up into one of these departments here, or separate itself into a work item. We are working on a few add-ins that would actually keep this a little bit more organized. But what we're going to do first is go ahead and say create work item. And again, we can give it a name. Let's just say test 1, 2, 3, a description, a major failure event, work event code. So if that's in the CMS type domain, we actually would have an event code that we can use and pull up. And again, this is to help that once we have the actual algorithm running and it trips this classification algorithm, we know a percentage that yes, this is the same exact issue that we saw previously, and we can send the appropriate alerts down the channels that would give them the work event code to verify, and kind of a descriptive and prescriptive message to allow them to know, okay, what do we need to do next? How was it solved in the first place or the last time it occurred? Again, causes, we can select the data set that we want to associate this data to. And if you think about it, the work item itself is more like a timestamp that we set within a data set to say, hey, at this time, we know that we had a specific type of issue, and let me see if I can find the failure pattern to match against all the other data and see once the first time I either saw this specific type of issue or what tags are associated to the specific type of issue. So here, for example, I'll put a demo compressor, the work event date. So here is to be a little bit cautious. I know with my compressor information, there is a timestamps from 2016. The work event dates themselves come from a calendar type standpoint. So if you have it with outside the bound, it won't show within your data set. So Because the data came for 2016, if I was to make it for, let's say today, August the 8th, 2019, it would not show up in the data set. So here I can go to pre-event type. So user defined is just specifically stating that the user gave us some of the information, some of the feedback from either CMMS or verbal confirmation that on this day, this time, they saw a critical failure or the line went down. Can you tell me what happened? There's also a calculated from unsupervised model. So these are the clustering type algorithms that we can bring in, have that anomaly detection, and from that anomaly detection determine, okay, what happened there. So if I was to select this, I can select a specific model that would help me figure out, okay, what happened there. And again, unsupervised model can be clustering or classification depending on how you manipulate the data or process the data. But here you can select which model you based your findings off of. So if you saw a specific failure in one of those algorithms, you can go ahead and select that. We'll do auto clustering here. And you can see it's already trying to give a pre-work event. It's looking for one of the largest anomalies and assuming that's what you're looking for. I'll go here and hit days. Again, all this data is coming from 2016, so the largest anomaly that it saw, it is trying to pick it up within that time frame. I'm just going to say 1 day, post-work event, 1 day. And again, so pre-work and post-work events are what we're telling the system to be good and bad data. And in this sense, we are saying, hey, the pre-work event may have the signature for the failure. We want to look 1 day in the past from the timestamp that we are given. And we are assuming that yes, that the failure mode is within that 1 day. And then the post event is just to state, okay, after this time frame, everything has returned back to normal operating procedures or normal operating mode. That way we can at least tell the system to say, okay, now we know what bad and what good looks like. Let's see what we can find. Let's investigate a little bit further. Also, the downtime itself is just a counter within our system that we can say, okay, how long was the system down? And we can correlate that to cost, to KPI, things of that nature. The work category, labor hours, cost, and again, this is all some of the metadata that we can take from either CMMS type formats, or we can verbally get from the reliability or maintenance teams, and then simply just hit create work item. And you'll see here, test 1, 2, 3, which was created today, is now one of those work items. We can also go and edit the work item in a sense of the name, a little bit more of description, and post and downtime, or post work events and downtime. One of the things we can't change is the pre-work event, because that's already what we're going to be using in the classification algorithms to determine what the tags were that contributed to this type of failure. And then what I just did here is I will go ahead and export the work items, and you can see it popped up a CSV file. If I go ahead and open that file, so now that we open the CSV file, we see that we have a user ID or a unit ID for the specific failure. We have the tenant, we have the data set, and the tenant itself is just going to be where this data is coming in from. And again, this is the example.com tenant that we're using, so that makes sense that it says example.com. The data set, which would go back into what we created in the beginning, the title or name of the specific failure, the description, the date, the problem cause, which is all metadata there, and then the pre-work, post-work events and downtime, which are all in seconds. The breakdown is a Boolean that's more for the metadata to ensure that it's a true breakdown, or that we're just going through the system itself and want to record that this may just be an investigation in process. The work category, the labor hours, total cost, and again, some of just the metadata that's there. And then once we do this, we can actually add in different titles for new set points. We can write a small script that would import a CMMS type file that's been exported from a customer to write into this Excel spreadsheet to give us what we need, so that now in one fell swoop, we can download 100 of these events and upload them back to the platform. And then once we have that, we save the file and then just hit import work items. And now all of those work items are now in our system and associated to those data sets. So now that we know a little bit more about the work items themselves, we can go back. I can either go to the home screen or to the projects tab. So I'm just going to click on the box here, which is the projects tab. Go to the demo anomaly detection. And then I'm just going to select the one that we created, the clustering algorithm, which is just the anomaly detection that we were using. So in the models, we see it's ready. I'll go ahead and select view. We'll let it load. And again, just a little refresher, it's a clustering type algorithm. The score is a pretty high score, 0.92. And again, the clustering algorithm score goes from -1 to 1. We could come down here, and what we want to map as a true anomaly would be what we see here in the middle of the data. And kind of just notes to have when creating these clustering type algorithms, we want to have enough data to balance out if we can see a true positive or a true negative. Some of these data, some of these anomalies that would happen in the front end of our data set can sometimes hinder where we say, okay, now we see that there's an anomaly here. But if that failure mode or that failure pattern is generated throughout this timestamp, we don't truly know what the lead time of failure is going to be. We can get a better idea at what tags are associated to this issue, but we can't tell how far that data goes without the data actually being there. So what we're going to do for an example is that I'm going to zoom in. Let me make sure synchronization is still there. I'm going to zoom in on this specific issue. And then so we see that maybe we had a failure event that is its own individual or independent failure event. We come in and we see that, okay, now there is some type of degradation between December 11th and December 18th. It peaks. Maybe there was a maintenance event that is a preventative maintenance event that helped slow down the curve, but you can see it came right back up and then shot up. Maybe there was a jam, maybe there was some type of issue that has occurred, and then reliability and maintenance team were able to come in and fix that issue or put a band-aid on it. And again, it started to have that degradation cycle, a failure, and then back to so-called normal type procedure or normal data. And you can see that it changes a little bit and then degradation comes back. And then finally we start getting a little bit more failures. And we're assuming from there that they actually fixed the root cause of the issue itself, allowed that data to go back or for the machine itself to come back to normal operating mode, and then continue on with what it was doing. So what we're going to do is that we want to capture what fixed that root cause, what fixed this major event. So what we're going to do is go ahead and click on this curve here. So this peak, when I click on it, you can see that now there's a pop-up at the top that says, do I want to create a work item for this data set? So now this is one of the things that we put in, so it makes it a lot easier to just go in and create these work items from scratch. Go ahead and click OK. As you can see, when you click on that OK, it opens up create work item. But the difference here is that the data set is already selected, and so is the work event date. Again, you can name this. So we're going to do the click event, description if we need it, work event code, cause, and then here we have the pre-event type. So what I'm going to do is say calculated from unsupervised model. And here we're just going to go ahead and select the clustering algorithm, which we clicked to create this one. And then days as a work event says 194 days. I believe when we saw it, I think 2 days is more than sufficient. And we'll do post work event 2 days also. Downtime 1 hour seems sufficient for that. And now we can go ahead and create this work item. So now that we have a work item, we can now go into the steps of creating the classification algorithm. So we're going to go ahead and go through that. So back to the projects, demo anomaly detection. And so what I'm going to do here is just going to do a random forest classification on the click event. And again, we're going to update the system a little bit more. Right now, we just are using titles that are very descriptive, but pretty soon we're going to have the ability to show the actual description of each individual one. So to kind of bring down any confusion that there is when actually looking at which algorithms you want to look or view. So random forest classification, click event, gonna select that for analysis. So now this is where the numerical and categorical tags really come into play. So for example, let's say that in this one we have a high pressure tag that correlates highly to some type of a critical failure event. What we can do there is now select it as a categorical tag, and then we can use it as our failure mode to train off of. So I'll show this in a second. We'll go ahead and click next. So now we're going to go ahead and click on classification algorithm, and the use response variable now would be that one that we selected as a categorical tag. Now we can use this as a response variable for the classification algorithm. But what we want to do is actually learn from the anomaly that we found from the clustering algorithm. So I'm going to go ahead and select include failure in learn. So here we'll go ahead and use the click event, and we can use auto select if wanted. So if we go to advanced settings here, again, the same thing we saw with the clustering algorithms. You have the ability to determine what kind of pre-processing you want to try out, dimensionality reduction you want to have to go through and cycle. We also have the ML learnings or the ML algorithms included, so decision trees, things of that nature. But what we're going to do here, just to save some time, we're going to go ahead and select the random forest. And again, in advanced settings, we have the ability to customize this algorithm, this flow, to create this algorithm. And it really helps in the long run for data scientists and those who are familiar with these type of platforms. But what we're just going to do is go ahead, random forest, and just use the default settings that they have associated to that. Click next, and again, version number. We only have one version of this data set, but let's say if we added 6 more months, we can append it to this data set here and just add it as 1.01 or 2.0, whatever naming convention you want to use. And so what we're going to do here is go ahead and click play. And now it's going to go through the process of creating our RF classification event. And it gives us the version day, when it was created, the data set that is correlated to this classification algorithm. And just like with the clustering, we have the ability to retrain these models using new data or appended data to the data set. We get to view the model itself, be able to use the offline predictor to verify and validate that it's still valid with new data coming in, or even use it for transferred learning. So let's say they're saying make a model, asset, or device, and they have the same number of tags. What we can do is deploy this as a startup phase to a different machine, or a same asset or a different asset with the same make and model. And now this classification can run real time and give us a good baseline for a specific type of failure. Then after, let's say, a few months of collecting data, now we have unique normalized data for that asset. What we can do now is use that data and either retrain this model, so now it's more focused towards that specific asset, or we can take that information and run it offline and validate and ensure everything's there. We can also use historical data on the offline predictor to also create a kind of validation step or tweaking step to ensure that if we deploy that classification to a new asset that is the same make and model, that we're going to get reliable results. Again, we can actually download this classification algorithm and manually upload it to the smart data collector. We can delete it from here, deploy it using the IoT tenant down to the SDC, and also on deploy it from the SDC. So we're going to go ahead and give this algorithm a few minutes to create. So now that the model is ready, we're going to go ahead and view what we see. So again, on the left-hand side, we have the model settings, which are the performance, so the scoring. And again, for the scoring of the classification type algorithms, we have it from 0 to 1. And so right now it's a pretty high score, 0.9956. And it gives us some of the setup information that we have that we use on the advanced settings. Up top, again, we have all the raw data that's in the features that we can go ahead and synchronize the graphs and do any more investigation if we want to. The anomaly score that is associated to what was going on with the data. We have the actual tick mark for the click event. We have the lead time to failure here. And as you can see, it's pretty close to what we're saying for 2 days. So there's a good chance that this may have been affected, and we may need to either reduce the time frame or open up the time frame to get a more accurate reading as to the failure mode. But for demonstration, this is fine. The anomaly boolean and response variable. One of the cool things here is that for the work items, we can go ahead and deselect any of the ones we don't want to see, and we only want to focus on the click event. Also, we can go over here, and again, we have the prediction and probabilities sections. Now we have a scatter plot if we want to see any relations to anything on the X and Y axes or any of the tags in general. But most importantly, we have the tag ranking. This gives us a better understanding as to the tag contribution from each individual tag to this specific type of failure mode. Now, take for granted that this failure mode may be a bit skewed for the sense that the lead time is very, very close to what we set for the pre-work event, but at least gives you a better idea of to see, okay, what tags really represent or what it picked up to be the main contribution to that type of failure. We also have the RCO curve too. So coming back into what we typically do here at SORBA is that we like to remind the customers that we're not SMEs. We don't know their machines in and out like they do. Their maintenance, the reliability teams are all the people who need to be in these conversations to really understand the impact that SORBA can make. We can provide lead time to failures. We can have tag rankings that associate these problems or associate these tags to a specific issue. But it's really the customer's team that sits down and helps us understand exactly what this really means. If it correlates to a critical failure event, if it does make sense in their eyes as to having these specific tags related to that issue, all of it works hand in hand. So again, we're not the SMEs, we're simply the data scientists coming in, or even engineers that are just coming in using this platform to try to get a better understanding as to the failure modes that are there, what kind of maintenance events to watch out for, and what really we can detect using this machine learning platform. SORBA provides all the different IoT installations that we need, from a smart data collector to the IoT platform to the machine learning platform you're seeing here. So there's a lot of different avenues to kind of provide solutions for those customers. And again, for this classification algorithm, it's for us to really understand that failure pattern, that failure mode for a specific type of event, either using a CMMS call to bring in that information as to the date and time of a specific event on an asset, or from us doing a blind test, going into anomaly detection and learning from a specific anomaly what really has occurred and what tags are associated to it, and then finally bringing this all together into either a report or to a meeting to talk to the SMEs, the reliability team, the maintenance team, to really understand the impact.